Gauss elimination method, GE method. A augmented B, elementary row operations, to U augmented C, AX is equal to B to UX is equal to C. Compare. In Gauss elimination method, use Jacobi iteration method. A11 x1 is equal to minus A12 x2 plus A13 x3 plus dash plus A11 1n xn plus B1 A22 into x2 is equal to minus A21 into x1 plus A23 into x3 plus dash plus A2n into xn plus B2 ANN into xn is equal to minus an1 x1 plus an2 x2 plus dash plus an minus 1 into xn minus 1 plus bn. Then x1 k plus 1 is equal to minus 1 by a11 into a12 x2 k plus a13 x3 k plus dash plus a1n xn k is equal to xn k plus whole plus b1 a11 b1 over a11 x2 k plus 1 is equal to minus 1 by a22 a11 x1 k plus a13 x3 k plus dash plus a n xn k plus b22 over a22 xn k plus 1 is equal to minus 1 by ann into a11 x11 k plus an x2 k plus dash plus an minus 1 xn minus 1 k plus bnn over ann. Remark: if initial approximation not given starting with it x0 is equal to 0 0 0, we generate the sequence of iterates x1 comma x2 comma dash which in the limit converges to actual exact solution, that is x. Sufficient condition for convergence of a Jacobi method is that system equation is diagonally dominant, a12 plus a13 greater than equals to a11, then diagonally dominant. If metric is Hermitian and or aii greater than equals to summation from j is equal to 1 to n j not equals to I, magnitude of aij 1 0 1 by 2 1 minus 2 1 1 1 minus 3. Necessary and sufficient condition for convergence is that special radius of the iteration matrix h less than unity 1 is the largest eigenvalue less than 1. Let magnitude a as eigenvalues 1 minus 1 minus 6, then spectral radius largest eigenvalue in magnitude is equal to 6 not equal to spectral radius. Since less than 1, if system is not diagonally dominant, even the system may converge if we rearrange it such that new system found is diagonally dominant, or convergence may be obtained even if the system is not diagonally dominant. When system is not diagonally dominant, then we may change the equations if possible such that new system is diagonally dominant and convergence is guaranteed. 45 2 3 minus 3 22 2 5 1 20 xyz into xyz is equal to 50 or 47 systems. Solve correct to two decimal places using Gauss Jacobi method starting with x0 is equal to 0 0 0. Here x1 k plus 1 is equal to minus 1 by 45 minus 2 minus 2 this one x k plus 1 is equal to minus 1 by 45 into minus 2 y raised to a k plus 3z raised to a k minus 58 x2 k plus 1 is equal to dash xn k plus 1 is equal to minus 1 by ann a11 x1 k plus a21 x2 k plus dash plus an minus 1 x k minus 1 k plus bnn x over ann. Gauss-Seidel method. A is non-singular. A11 x1 plus A12 x2 plus dash plus A1n xn is equal to b1. A21 x1 plus A22 x2 plus dash plus A2n xn is equal to b2. An1 x1 plus An2 x2 plus dash plus Ann xn is equal to bn. Ai not equal to 0. K x1 k plus 1 is equal to 1 by A11 into b1 minus A12 x2k plus A13 x3k plus dash plus A1n xnk x2k plus 1 is equal to 1 by A22 b2 minus A21 x1k plus 1 plus A23 x3k plus A2n xnk. xnk plus 1 is equal to 1 by Ann into bn minus An1 x1k plus 1 plus An2 x2k plus 1 plus dash plus Ann minus 1 xn minus 1 k plus 1. Iterative formula for Gauss-Seidel method. A x is equal to b 45 2 3 minus 3 22 5 1 20 x1 x2 x3 58 47 67. x1 k plus 1 is equal to 1 by 45 58 minus 2 into x2 k plus 3 x3 k x2 k plus 1 is equal to 1 by 22 47 minus 3 x1 k plus 1 plus 2 x3 k plus 1 is equal to 1 by 20 67 minus 5 x1 k plus 1 plus x2 k plus 1. First iteration x0 is equal to 0 0 0, x1 0 is equal to 0, x2 0 is equal to 0, x3 0 is equal to 0, x1 is equal to 1 is equal to this 58 by 45, x2 1 is equal to this. Similarly x1 2, then x2 2, then x3 2, x1 3, third iteration x1 3, x2 3, x3 3, then x1 4, x2 4, x3 4, magnitude of x1 4 minus x1 3, magnitude of x2 4 minus x2 3, magnitude of x3 4 minus x3 3, x1 is equal to 1.000, x2 is equal to 2.000, x3 is equal to 3.000. If magnitude less than 0.405, then implies then stop. x0 is equal to 0 implies x1 0 is equal to 0, x2 0 is equal to 0, x3 0 is equal to 0, x is equal to x1, x2, x3, x is equal to 1, 2, minus 3. Magnitude of x infinity is equal to maximum xl. Magnitude of x then infinity is equal to maximum x1, x2, x3 magnitude curly brackets. Magnitude of xk plus 1 minus xk into magnitude infinity over xk magnitude into over magnitude infinity is equal x2 minus x1 magnitude of magnitude x1 1, x2 1, x3 1, x4 1 minus x1 square, x2 square, x3 square, x4 square is equal to this.